I am going to discuss the flammable limits, which will have a serious impact on how you store flammable materials in the workplace. So what is the flammable range then? The flammability range is the range of percentage of vapour or gas concentration by volume in air between the upper and lower limits of flammability. So it's the range of the lower and upper limits, that's the flammable range. Some have got wide flammable ranges and some have got narrow flammable ranges. But it's always the percentage of the vapour in air, not air in vapour, it's the percentage of air in vapour. Now, there are two limits, namely the LEL and UEL, which is the lower explosive limit and the upper explosive limit. And these are interchangeably with the LFL and UFL, which is the lower flammable limit and the upper flammable limit. They're the same principle actually. But it's LEL, UEL, LFL, UFL. The mixture will not burn when the composition is lower than the flammable limit or higher than the upper flammable limit. So you've got to be between the lower explosive limit and the upper explosive. Those percentages, it's got to be between those concentrations to burn when an ignition source is applied. So let's go again, the LEL. This LEL is the lowest concentration of fuel vapour when mixed with air that will burn when an ignition source is applied. And the upper explosive limit is the highest concentration of fuel vapour mixed with air that will burn when an ignition source is applied. So there's the lower explosive limit and the upper one. Let's explain this then. An example, an arsonist walks in a room with a little can of petrol and he pours it in the corner. Petrol's got a flash point of -40, so straight away the vapours are being released. He comes along to the corner of the room, the vapour starts to get to him, and the LEL, the lower explosive limit of petrol, is 5%, and the upper is about 12%. So that's the flammable range of petrol, between 5 to 12%. Now he comes along, the vapour starts to come to him, he gets a match out, and he lights a match when the petrol vapour is 3% in air. So there's 3% of petrol vapour. Will it burn? No. You've not reached the lower flammable limit. Okay? So, he leaves it a bit longer, it gets to 6% vapour where the match is, and he lights a match. Will it burn? Yes. Because it's between the 5 to 12% it will burn. And what you'll see is as he lights it, the flame will go straight back to the container and the liquid will burn. That's it. Now, that's how the flammable limits work. Now, what happens if this arsonist is a real bad one, he brings in 50 gallons of petrol and he pours it in the room. And he fills that room with 25 to 30% petrol vapour in air. So there's at least 30% petrol in the air. And he tries to light a match. Will it burn? No. You've gone outside the limits. It's not, you've gone above the upper explosive limit. That's what this is all about with the flammable limits. Now, on the same point with this, flammable limit, what happens if you've got an atmosphere fully between the LEL and UEL? So you come in here, you put in 5 gallons of petrol, you let it vaporise, and the whole room is between the flammable range. So the whole room has got an atmosphere between 5 to 12%, and you light a match. What will you experience? An explosion. Do you see what's happening? The whole room explodes because the whole room is between the LEL and LFL, whereas if only part of it is, you'll see a fire when it goes back to the cylinder. That's the difference. That's the difference. Look at this table here. The flammable limits of petrol about 5 to 12%. Acetylene is 2.5% to 80, something like that. So acetylene is a very volatile gas. Hydrogen is 4 to 74, depending on which data you look at. Carbon monoxide, which is a flammable gas, a product of incomplete combustion, is 12.5% to 74, so that's quite wide. Methane, 5 to 15, not a very volatile gas. Acetylene, 2.5 to 80, so there's another volatile gas. The wider the limits, the more volatile the gas is considered to be. Now these limits, these flammable limits, are in air. What happens if you increase the oxygen concentration? What happens to those flammable limits? Well, they're widened. If you increase the oxygen, as you increase it, it widens the limit. It makes the gas more volatile. And eventually it gets to the point where any gas in that atmosphere will create an explosive atmosphere. What happens if you inert an atmosphere? You pump in nitrogen. What happens to the flammable range when you start to inert an atmosphere? Well, they get narrower and narrower and narrower. And in the end, if you fully inert a gas, there's no flammable range. It's gone out of it. Do you see how oxygen concentration increases the flammable range? Inerting decreases the flammable range until combustion ceases. Now, how do you tell if an atmosphere is explosive? We can get an explosimeter. This is an instrument that's used to determine the quantity of gas in the atmosphere. For example, if you're looking at LEV, local exhaust ventilation requirements, the person will normally take in an explosimeter and take samples of the gas to see if an explosive atmosphere is created. And in fact, in the fire brigade, we have explosimeters. Say, for example, we're called to an incident and there's been a gas release, like, for example, acetylene. We have to work out if it is an explosive atmosphere, and we'll take in this explosimeter. What an explosimeter does in simplest form is it draws in the atmosphere and it attempts to burn it. You have to select the gas you're looking for. You can't just say any gas. You have to select it, and say you set it as acetylene, go in the atmosphere, it draws it in and it starts to beep and it goes out. Now you go in there and it says 10%. 10%. What? 10% of what? Well, it's not 10% acetylene. You are looking at 10% of the LEL. You are only at 10% of the lower explosive limit. And as you go in there, further in the room, it goes up and up and up and up and up. When it gets to 100% on an explosimeter, what that means is you are now at 100% of the LEL. In other words, you are now entering an explosive atmosphere. I used to do a lot of training for the firemen, and sometimes you say, no, I'm not interested. They're the ones going in. They need to know that. That's what it means. 100% does not mean 100% acetylene. It means you are at 100% of the LEL. You are now in an explosive atmosphere. So these are the definitions. LEL, UEL, etc.